Okay, question 3. So when uranium-235 absorbs a neutron, the nucleus splits. This is called nuclear fission. How many daughter nuclei are produced? So we know we split it into 2 smaller bits and we make 2 to 3 neutrons. So it's trying to catch us out. We can see that there. There's the uranium. It absorbs it. This makes it unstable and it splits. And there's the 2 daughter nuclei and we've got 3 neutrons there. The crucial part is it's split into 2 smaller pieces. The next one, when it splits, neutrons are emitted. The neutrons can start a chain reaction. Describe it. So if I've got a little picture here, so this is the idea that we absorb it into, so a neutron's absorbed if the neutron's at the right velocity. This makes the nucleus unstable. The nucleus splits to make 2 daughter nuclei and then produces, we can see we've got 3 neutrons. Well, those 3 neutrons will then go on to hit 3 more nuclei. And we can see we've then got this exponential growth. We've gone from 1 to 3 to 9, and you can see what's going on here. We're just going to rapidly get a reaction that goes out of control. There's a nuclear bomb. So the crucial parts now, what is meant by a chain reaction? Neutrons are absorbed by a uranium nuclei with the correct velocity. That's really important. Okay. So the next part is, this makes the nucleus unstable and splits, producing 2 to 3 neutrons. So got that idea now. These neutrons split more uranium nuclei and the growth is exponential. And there we go. That's it. Now, it says you can draw a diagram. So that pretty much says everything that you need. That diagram's pretty good. But it's this idea that neutrons with the right velocity are absorbed. This splits it. This makes more neutrons. Those neutrons go on to be absorbed by more nuclei, uranium nuclei, and the growth is exponential. It's getting bigger and bigger each time. Next one. In the nuclear reactor of a power station, the chain reaction has to be controlled. Explain the action of a moderator. So that's a harder one. So the job of the moderator is to affect the velocity. So most of the time, these neutrons are going so quickly that they'll literally just pass by the nucleus or through the nucleus. But if it's at the right velocity, then it will be absorbed by the large nucleus. All right. So that's this crucial idea. We've got to get the velocity right. So what does a moderator do? Well, it changes the velocity. It's actually going to give more of the neutrons the right velocity, and therefore there's going to be more reactions. So it reduces the velocity of neutrons. I could even say in there, more neutrons have the right velocity. All right, so this is the same here. So it changes the velocity or reduces the velocity of the neutrons. So more neutrons have the correct velocity to be absorbed, and therefore there's a increased probability of fission, or there's a higher rate of fission. On to the next one. A nuclear reactor says there is 2 times 10 to the 17 reactions every second. Okay, that's how many are going on. Huge number. And it says, and each time one of these takes place, it releases that much energy. Calculate the energy released in 1 second. So I just go back up to the question. It tells me there, well, that's how many reactions each second. So that's how many are taking place. And then all I need to do is just multiply it by each bit of energy I get from those. So it's just times the 2 numbers together. So times them together and we get 8 times 10 to the 6. And the last part now is about nuclear fusion. So fission is splitting nuclei. Fusion is joining little ones to make some big ones. So describe what happens in nuclear fusion. So small nuclei, like hydrogen, we start with that, are joined together to make large nuclei. Easy 2 marks. High temperatures and pressures are required to overcome the repulsion. So we've got these positive nuclei, these positive hydrogen nuclei, and they just want to be away from each other. So we're going to use huge temperatures and pressures to squeeze you together. And when we do this, a small bit amount of mass is lost, and that's converted to energy according to E equals mc squared. It's actually a model answer, and it's kind of like any 2 of those key bits. And that, that's enough there for a good higher tier answer as well.